Professor, my PPT is visible?
Still not yet. I think you can start sharing again. Share your slide first, Professor. Now you can slide. It was previously only one side. Oh. Right, please.
Yeah. Now I will say. Screen. Now it is visible,
Okay,
sir.
yeah, it's visible, so you can do it. The slideshow. Okay. Thank you so much. Good morning, everyone. Welcome to our fourth special lecture session. This is Shahriar, and I will be the host of this session. Today we have one lecturer, is our facilitator from India, and he will discuss about the solar thermal and solar thermal. Before I invite our facilitator, I would like to introduce him. He graduated from electrical engineering in Chennai, and also MSc engineering from engineering energy field and National University in Chennai. And he got PhD degree in mechanical engineering field in 2019. After that, he joined as the assistant professor B.S. Abdul Rahim Crescent Institute of Science and Technology in Chennai. His research areas solar thermal desalination, solar water heater, and solar PV. He has been published more than 124 ISI journal and 2 book chapters, and 51 conference. In addition, 5 national conference publication. Not only that, his citation more than 3,500 and H index 36. He has been selected a top 10% scientist once in 2020. And also he has been selected the best young faculty members in India 2019 to 2020. And in 2020 and also 2021, he has been selected as a top 2% researcher in the world, which is evaluated by the Stanford University and Elsevier. So within further ado, please help me to welcome our facilitator, Dr. Muthu Monokor. Dr. Muthu, professor, please.
Thank you very much for your nice introduction, Professor. Can I know who will be the attendees, whether they are a UG student or PG student?
We have both student and our session actually 9 to 12, and then 1 hour break, and then 1 to 2. And we are going to recording, and we'll share that video with our student in the class.
So now only participant is only 2 members. You and
yes, Prof, we will will join because we have many online session. So our recorded video will share with our student.
Okay.
Okay, thank you.
Okay. Good morning to all. So today my presentation is titled on a fundamental concept of solar water heater utilization and energy storage system. So today my presentation will consist of introduction to different types of energy, introduction to renewable energy, introduction to solar energy, the different types of solar water heaters, energy storage system, and the final session should be how to do a research in solar energy system. So first, what is mean by energy? So it is the capacity for doing a work. It consists in many forms: kinetic energy, potential energy, thermal energy, electrical energy, chemical energy, nuclear energy, and other various forms of energy. So first, what is mean by potential energy? Potential energy means energy stored within a particle, or it can be released when it is moved from one form to another form. It is called potential energy. Kinetic energy means movement of air, like in you consider a wind turbine. So how it will works? When the air is flowing from one place to another place, due to the movement of air, kinetic energy will be generated. And thermal energy, already in the recent trend, we have utilized most of the thermal energy that is generated from the sun. And the chemical energy, methane and nuclear, that is uranium, it consists of chemical energy. So the main thing is heat and work. It is called energy, the process of transfer of heat from one body to another body. Energy is a conserved quantity. The law of conservation of energy states that energy can be created, but it not be energy can be converted in one form to another form, but not created or destroyed. So it is the law of energy conservation. So heat energy. So we can feel the warmth that is generated from the sun. So it is called heat energy. Light energy. So we can get both the heat energy and light energy from the sun. Heat energy may be used to produce steam, which can be run the turbine and it can produce electrical power. Light energy. We can use light energy by utilizing the solar photovoltaic panel. So it converts light energy to electricity. Sound energy, it is also one form of energy. Kinetic energy. So already I told you, so due to the movement of air from one place to another place, wind turbine should be rotated. So due to the movement of wind turbine, mechanical power is produced. This mechanical power is converted into electrical power. It is called kinetic energy. So here it shows one man is running. So it is kinetic energy. Potential energy means it should be at a rest position. You can consider hydro power plant. In hydro power plant, water is stored in the dam. When the dam door gets open, then water will be flowing from top to bottom. So due to the movement of water from top to bottom, due to the kinetic energy, we can run the hydraulic turbines. So here, potential energy is converted into kinetic energy. When water is stored in the dam, it is called potential energy. When its door gets open, so water is flowing from top layer to bottom layer, so it is called kinetic energy. Once it reaches the hydraulic turbines, here kinetic energy is converted into mechanical energy. Again, turbine is coupled to generator. So now mechanical energy is converted into electrical energy. So it is the energy conservation for hydro power plant. Similarly, for chemical energy, we can consider both the coal thermal power plant as well as a nuclear power plant. If you consider coal thermal power plant, chemical energy present in the coal is converted into heat energy. Here, chemical energy is converted into heat energy. Again, heat energy is converted into mechanical energy. How means in the thermal power plant, coal is utilized for burning the water, so that water will converted into steam. So here the conversion of water to steam is called kinetic energy. Once again, this kinetic energy is directly sent to the turbine. So here in turbine plates, the kinetic energy of steam is striking the turbine, so that turbine will rotate. So here energy is converted from kinetic energy into mechanical energy. Once turbine starts rotated, here we can produce mechanical energy. This turbine is directly coupled to generator, so that here mechanical energy is converted into electrical energy. So this is the energy conversion principle of chemical energy. So the energy is converted from one form to another form. Chemical energy is converted into heat energy. The heat energy is converted into mechanical energy. Mechanical energy is finally converted into electrical energy. So this is the energy conversion of coal thermal power plant. So the same process is applicable for nuclear power plant. In the thermal power plant, we can use coal as a fuel, whereas in nuclear power plant we can use nuclear fuel, that is uranium we can use. In the nuclear power plant also the same working principle. The chemical energy which is present in the uranium fuel is converted into heat energy. Heat energy is converted into kinetic energy, where the turbine is rotated. The same principle. In the thermal power plant, we have boiler, whereas in nuclear power plant, we have nuclear reactor. So this is the basic principle, basic difference between both the thermal and the nuclear power plant, but the working principle is the same. The kinetic energy is converted into electrical energy by integrating with turbine and nuclear turbine and generator. So this is the energy conversion principle of chemical power plant. So electrical, it is one form of energy. Gravitational energy, elasticity. So these are the some kind of energy forms. So there are two main types of energy. So already I explained everything. The main classifications are potential and kinetic energy. So potential energy means energy that is stored in the particular component, for example, mechanical energy and nuclear energy. Whereas the kinetic energy means energy of motion. So we can consider light energy, sound energy, and thermal energy. These are belongs to kinetic energy. So see here a carbon which consists of so energy stored in the nucleus of an atom holds atom together. So this is the one example for potential energy. So the energy which consists of uranium particle, which is used to produce the or which is used to convert the energy from one form to another form. So it is called potential energy. Chemical energy, here we can consider methane. So the chemical formula for methane is CH4. It consists of one carbon and 4 hydrogen. So energy stored in the bonds between atoms. Here molecules holds together, and the methane gas is used for producing the heat energy. So again the heat energy is converted into mechanical energy. So this is explained for potential energy. So prefix for power in watts. So these are the common unit which will be applicable for measuring the power in watts. So 10 power minus 3 milliwatt, 10 power minus 6 microwatt, 10 power minus 9 nano, 10 power minus 2 picowatt. So here, see here, 10 power 3 kilowatt. So watts is a basic unit. Watts means joule per second. The amount of power which is generated per second. Per second it is generated. Joule per second is called watt. Joule per second it is called watt. Watts. So kilowatts means 10 power 3. 1000 watts is called 1 kilowatt. Similarly, 10 power 6 is called 10 power 6 means 1000. Yeah, 1 lakh watts is equal to megawatt. 10 power 9 watts is equal to gigawatt. 10 power 12 is tetrawatt. So commonly these are the watts we will usually use in the calculating purpose as well as day to our life. So kilowatt, megawatt, gigawatt, and terawatt. 10 power 3, 10 power 6, 10 power 9, 10 power 12. So see this pie chart. So this is the world energy, primary energy consumption by country and region wise. So if you see this chart, it is very clear that around 21.7% primary energy consumption is utilized by United States. So after that, Europe utilized 17.5% primary energy consumption, and China, they are utilizing 14.5% energy utilization. So, so after US, Europe, and China, Russia is in fourth place. They have replaced the 6.6% energy consumption, and non-Asia countries they have replaced 5.8. Central and South America they have replaced 5.1. Middle East countries they have replaced 5%. Japan 4.9%. And other non-Europe, that is Commonwealth states, they have replaced the 4.4. India, we are using 3.5%. Africa 3.1. Canada 3.1. South Korea 2%. Mexico also 2%. So these are the primary energy consumption, which will be classified by country as well as region. And Australia and New Zealand, they have. I think the land per capita land they have replaced is very less. So that the energy consumption by New Zealand and Australia is very minimum. That is 1.4% only. So history of how the work had done. So during the olden days, first work has to be done by using slaves. So here slaves are used to run the vehicle. So this is the first work we get. Then next, the human slaves are replaced by domestic animals. Here horse is used to run the vehicle. So when the automobile industry has developed, once the vehicle has arrived, that is internal combustion engines has developed, we can compare the performance of IC engine with respect to horsepower. So still up to till date we have used horsepower. That means, for example, one horse, how many kilometers it can run. So it is called horsepower. So still we are using the same horsepower for measuring the engine performance. So after slaves, we have utilized the domestic animal like a horse to run the vehicle. So I think around 19th century, windmills has developed. So it can be used for producing some mechanical power. It was used to grinding some floor as well as some wood. So after some years, steam chips were introduced. So after that, gasoline engine it is used to drive the aeroplane and the helicopter. Also, we have used IC engines. I think around 100 years back we have developed IC engines. So now recently we have a petroleum power plant as well as a nuclear power plant, coal thermal power plant. So these are the how we are getting work done. So after internal IC engines developed, we have produced enormous amount of car, bikes, as well as four-wheeler vehicles. All these IC engines are run by petrol and diesel. So we can easily move from one place to another place. The main disadvantage is emission. It consists of SO2 and NO2. It can produce acid rain. So now recently we have changed to electric vehicle. So I think all the countries they have initiated to start their EV project. So first, before going to a renewable energy power plant, we will see what are the conventional, that is non-renewable power sources are available. First, we will see their merits and demerits, and we will see renewable power plant. After that, we will focus solar energy. After that, we will particularly focus on some solar water heating techniques. So first, what is meant by non-renewable energy source? Non-renewable energy comes from sources that will not run out or will not be restored in our lifetime, or even in many years it will take to reform. The examples are petroleum, natural gas, coal, and nuclear. So the formation of petroleum, natural gas, and coal required several millions of years. After that only we can get this product. So see this diagram. So millions of years required, and photosynthesis exceeds decomposition. It will form tetrabuates, that is millions of years it required accumulation of tetrabuates. So once organic matter buried under the sediments, due to so many years, maybe millions of years, heat and pressure will be generated under the earth's surface. So the result of organic matter, which is under the earth, which will produce natural gas, oil, and coal. So these are the natural resources. So once we can take this natural gas, oil, and coal, we can utilize it for the power production. So once again, the main problem is when the vehicle is operated, it produces heat energy as well as CO2, NO2, and SO2, nitrogen oxide, and sulfur oxide. So this SO2 and NO2 is the main reason for acid rain. So once it will mix with rainwater, it produces acid rain. So already I told you, for making or for natural creation of natural gas, oil, and coal, it will require millions of years, not hundreds or thousands of years. It requires millions of years. So already one literature shows that we are at the I think the coal will be available for next 50 years, and oil will be available for next 60 to 100 years. So after that, in the earth, there will be no natural gas, no oil. Recently, I think last 4 to 5 years back, Japan has stopped all their coal thermal power plant. So the reason is environmental pollution. Also, United States and Japan, also some, I think Russia, they have stopped building new nuclear power plant. Since the reason is the waste recycling of nuclear power plant, it required a huge amount of investment. Also, it is threatening to their country, so they have stopped nuclear power plant. In some country, they have stopped coal thermal power plant. They are fully focused on a solar power plant, solar PV and solar thermal. In some countries, they have developed a wind turbine power plant. So due to the movement of wind, we can generate the electrical power. Some country developed biogas plant. So these are the some new and renewable power plant. So already we seen non-renewable power plant. So it depends on coal, natural gas, nuclear. So it needs millions of years to form in the earth. So now we will see what are the different types of renewable energy. So renewable energy is any energy source that is naturally restored. like that derived from solar, wind, geothermal, hydropower plant, and biomass, ozone energy, tidal energy, hydro energy. So these are the renewable energy sources. So we can naturally restore its back in the country. For example, first one, solar PV. It is one of the important renewable power plant. So solar PV means the conversion of light energy into electrical power. It fully depends on light energy. It consists of P-type material and N-type material. When the solar energy strike the P-type layer, electrons which present in the P-type layer is moves from P-type layer to N-type layer. So due to the movement of electrons from one layer to another layer, we can create a DC power. So it is the working of solar photovoltaic. So the main drawback in solar photovoltaic is recycling of solar photovoltaic panel. After that, the lifetime of solar panel may be 15 to 20 years. So after that, it should be recycled. So it is one of the major challenging in use of solar photovoltaic. Solar thermal power plant. So first one, solar PV, it replaces light energy. Second one, solar thermal power plant, it utilizes heat energy. So the amount of heat energy which received on the collector or concentrator will be focused on the particular place, so that the heat energy is converted into steam. So we have used water. So water will be continuously heated, so that water will be evaporate, so that it produces steam. So the produced steam is utilized to strike the turbine blades. So already we seen thermal power plant and nuclear power plant operation. In coal thermal power plant, we have used boiler. So in boiler, we can get a heat energy by burning the coal. Whereas in solar thermal power plant, we have utilized concentrator. There are around 4 different types of concentrator is available. That is a parabolic rough collector, parabolic disc collector, linear Fresnel reflector, and another one is cylindrical compound parabolic concentrator. So these are the concentrator which replaced instead of boiler. So the boiler can be replaced in the solar thermal power plant, so that instead of boiler we can use solar concentrator. So concentrator concentrate heat energy. In the coal thermal power plant, coal is used to produce heat. In solar thermal power plant, concentrator is replaced to produce heat. So the same working fluid. In the coal thermal power plant, we used water. The same working fluid is replaced in solar thermal power plant. Here also the same water is used as a working fluid. So water will be heated, and once it reach boiling point, so steam can be produced. So again the cycle is the same. Turbine consists of a number of plates. So steam strike the turbine plates, so that turbine should rotate. So here kinetic energy of steam is converted into mechanical energy. Once again, turbines are connected to generator. So the mechanical energy which is produced is converted into electrical energy. So these are the working of solar thermal power plant. So we can get both light energy and heat energy from the sun. And the third one is wind power. So wind, the movement of air from one place to another place. So to do the movement of air from one place to another place, we can run wind turbines. So here, when the air strike the wind turbine, it will be rotated. So here, kinetic energy which is present in the air is converted into mechanical energy at turbine. So again, turbine is connected to generator. So here, mechanical energy is converted into electrical energy. So the energy conversion process of wind turbine power plant is kinetic energy. Kinetic energy is converted into mechanical energy. Kinetic energy is the movement of air. Mechanical energy is the movement of turbines blade. Again, mechanical energy is converted into electrical energy. So these are the energy conversion principle. Hydropower. So in hydropower plant, water is stored in the dam. Water is stored in the dam. Here it is potential energy. Water is stored in the dam. So it is called potential energy. It is stored. When the dam door gets opened, the stored water is flow through the large tube. It is called penstoke. It is called penstoke. So when the water is flowing in the penstoke, its pressure gets increases so that it will moves in a higher mass flow rate of water. So that here potential energy is converted into kinetic energy at penstoke. Once it reach the downside of penstoke, here hydraulic turbines are there. So it will force the turbine blades. In the coal thermal power plant, steam is used to strike the turbines, whereas in hydro power plant, water is used to strike the turbine blades, so that it will converted into kinetic energy is converted into mechanical energy. So again, the same mechanical energy is converted into electrical energy by utilizing the generator at turbine blades. So that once mechanical energy developed in turbine, it is converted into electrical energy. And fifth one is biomass. So the waste, that is solid waste, agriculture waste, commercial waste, all the waste can be utilized to produce biomass by using different techniques like pyrolysis, incineration. So these are the techniques available to produce biomass. We can either produce biomass or biogas. Even biogas is utilized to run the gas turbine plants. So we can use it as a raw material for generator also. And the ozone energy. In the ozone, we have two types of energy, wave energy and tidal energy. We can build tidal power plant at ozone, but it required huge investment. We have to use uncorroded material. Also, the technologies, which is very, very new one. I think some developed countries developed these type of power plants, but it is not available in India. Geothermal energy. So in some places, when we drill under the earth, we can get a steam, whereas in some cases we can get some heat energy. If a steam is available, we can directly get that steam and we can run the turbine and we can produce electrical power. If steam is not generated, we can get some heat energy. We can replace this heat energy for producing hot water, and we can replace it for producing. These are examples for geothermal power plant. Now we will see what is meant by world energy resources. World energy resources. It is estimated maximum capacity for energy production given all available resources on Earth. So for example, in particular amount of energy is used throughout the world means, so that is estimated maximum capacity for energy production given all available resources on Earth. It can be divided by type, that is fossil fuel. Under the fossil fuel, it becomes coal, natural gas, and nuclear fuel and renewable resources. So these are the world energy resources. So the amount of energy which is released from the sun during the 1 hour is equal to the amount of world energy utilization per day. Per day. So 1 hour we have received how much amount from the sun throughout the world is equal to we have utilized per day. But we cannot consume all the energy which will receive from the sun. So this is the main disadvantage. We can replace not replace all the 100% energy which is released from the sun. So now we will see resources. So first one is oil resources. So it is one of the important resource. So see here. So the total North America, they have around 236.7 thousand of million barrels oil resource. So as compared to previous years, that is at 1998, they have only 100,000 million barrels of oil resource, whereas now they are having 236,000 million barrels. So next, Central America. First one, North America, they are Central America. At the end of 1998, they have 95 million thousand barrels oil, whereas now at the year of 2018, they have 325,000 million barrels of oils. So where they have taken these resources in their country, it is available. Oil reserves are available. They have in the underground, they have bred and they have used some techniques to extract the oil. And they have, after taking the raw oil, they have did some reprocessing techniques, and they have take petrol, diesel, and some other kind of composition. And Europe, so they have only minimum oil reserve, whereas in Europe they have natural gas high amount, whereas in oil reserve they have only minimum amount. In 1998 they have 21.4 thousand million barrels, whereas in 2018 they have 14.3 million thousand million barrels. So oil reserve they have minimum. So see here, so they are Middle East country. They are rich in oil reserve. Iran, Iraq, Kuwait, Oman, Qatar, and Saudi Arabia. See here, they have 261. So total North America, they have only less than 250. Whereas here, one country, that is Saudi Arabia, they have around 261,000 million barrels of oil reserve. And in Middle East, next Iraq have 12.5 thousand million barrels. So the recent war, continuous war in the total Middle East is for the oil only. So the developed country, America, United States, they are they are doing continuously politics in Middle East country, so that they have continuously war. So the oil richest country is Middle East country, in particularly Saudi Arabia and Iraq. Syria have only minimum oil resource. Kuwait has 96, Iran also 93. So after that, Africa. In Africa also they have 125.3 thousand million barrels of oil. So see this chart. So Middle East. So from the orange lines are Middle East. So they have 60 million thousand barrel oils at the year of 1998. Now it is decreased to 48.3 million barrels of oil. So continuously oil resources are decreasing in the world. Every places. See, after Middle East, I think CAS, Commonwealth Independent States, which is near to Russia. So see their resource also decreasing trend, 10.6, 9.7, and 8.4 thousand million barrels. So after maybe around 50 years, now we are in 2023, after 50 years, maybe 2070, the oil resource may be decreased huge amount. So here Middle East have 48, maybe at the end of after 50 years, they may have 20,000 million barrels oil. So other countries like Commonwealth Independent States and Europe, their oil resource must be less than 10,000 million barrels after the 50 years. So these are the oil resource. So next, natural gas. So inside the earth, we have some places we have natural gas. So see, total North America, they have only 13.9 trillion cubic meter natural gas. And Central America, they have 8.2. Total Europe only have 3.9. Total Europe only have 3.9. So again, see here 14, whereas in Middle East they have 75 trillion cubic meter. See here again Iran, they have a huge amount of oil resource as well as natural gas resource. So after Iran, I think Qatar have 11.3, Saudi Arabia 5.8, UAE 5.8. So these are the natural resource which is available in Middle East. So in Africa also they have 14.4. Now we will see coal. Coal. So it is one of the important natural resource which will be useful for producing electrical power. So last I think 50 to 60 years, the coal thermal power plant has been developed, and many countries they have installed this type of power plant. Now we will see resource how much they have. So totally North America, I think they have a huge amount of resource. 2,58,000, and Europe they have 1,34,000. It is half the amount of North America. So in Middle East they have 1,44,000. In Pacific, Australia have 1,47,000. China has 1,38,000. India has 1,13,000. Indonesia has 37,000. So these are the some resources. Thailand, they are having 1,063 tons of coal. So it is as per 2018 statement. They have reserve, coal reserve. Vietnam also they have 3,003. Other Pacific. So totally 10,54,782 tons of coal available. Now uranium resource. Uranium resource. So see here, Australia has 30% of world's uranium resource. They have huge amount of uranium resource. So after Australia, Kazakhstan has 14% uranium resource. Canada have 8%. Russia also has 8% resource. Namibia has 7%. South Africa 5%. China 5%. Niger 5%. Brazil 5%. Ukraine, Mongolia, Jordan, all the countries have uranium resource. So in the uranium also, the reprocessing of uranium is very, very difficult. Similarly, during the mining also, there is a chance for uranium leakage. It will affect the human beings as well as natural resource like plant, animals. Everything will be affected by using uranium radiation. Now, solar PV. So, China, they are at #1 position. They have installed around 1,73,000 megawatt solar power plant. So after that, China, Europe, they have installed 1,15,234 megawatt power plant. So while considering solar PV, United States are at #3 position. They have installed 68,200 megawatt power plant. So the reason is US has maximum number of uranium power plant, that is nuclear power plant in their country. So they didn't start solar PV power plant. Maybe in future, maybe after 10 years, once they have stopped all the nuclear power plant, they should be before the China. They should be before the China. Japan is at 4th place, Germany at 5th place, India 5th place. They have produced around 26,869 megawatt power plant. And Thailand is at 18th place. They have produced 2,720 megawatt power plant. They are at 18th place. Maybe in the future, your country will move to less than 15 places. The reason is Canada, Mexico, and Belgium, they are a small country. Netherlands also small country. So you can beat these 4 countries by utilizing some government initiative by your Thailand government. So you are at the 18th place. You are replacing 2,720 megawatt power. Now we will see energy cycle of the earth. So 100% of incoming solar energy, here it is there. So it will not reach the earth's surface. The reason is some percentage of solar intensity is reflected by the atmosphere. So it is 6%. If clouds are there, 20% of solar intensity will be reflected back to the atmosphere. If clouds are not there, this 20% maybe comes to the ground. 4% of solar intensity is reflected back to the atmosphere from the earth's surface. So we can receive only 90% solar radiation. If clouds are there, we can receive only 70% solar intensity to the ground. So absorbed by atmosphere 16%, absorbed by clouds 3%. So this one is reflected, and here absorption. So 16% of solar intensity is absorbed by the atmosphere. Absorbed by clouds 3%, conducting and rising air 7%. So maybe 60%, 64% radiation to space from clouds and atmosphere. So these are the energy cycle of the earth. So we cannot receive all the 100% solar energy which is released from the sun to the earth. So based on the days, if cloudy days, 20% reflected back to the earth's ambient, and absorbed by 3%. Around 23% will be decreased by clouds. Now, environmental aspect of energy utilization. First one, greenhouse effect, the global warming. Second one, ozone layer restriction. Third one, acid layer, acid rain formation. So when the CO2 and NO2 mixed with rainwater, we will get acid rain, radiation, and health. So if you used nuclear power plant, some radiation continuously will be releasing into the environment. So it will affect the human being. So some cases they will humans will get brain cancer, blood cancer, skin cancer. So these are the environmental effect of nuclear power plant. So effect of fossil fuel production. So we cannot simply get fossil fuel like solar energy. We have to take it from the earth by mining and drilling. So considerable environmental damage results from mining and drilling. So when the fossil fuel is get it from the underground, we have to drill it so that we can get some air pollution. When the machine is operating, drilling machine is operating, it will pollute the air. Similarly, water will be polluted. Water will be polluted. Also, road damage. Road damage. Underground mining is extremely hazardous, and old mines sometimes catch fire. It will ban for up to 10 days to some years. So it will take. From mining, we cannot easily control the mining fire accident. So these are the effect of fossil fuel production. So drilling for petroleum and natural gas often results in release of briny water to the surface into stream, causing damage to the stream life and sometimes rendering the water unfit for human consumption. Even after some treatment also, we cannot consume this fuel. So these petroleum product can be used to produce gasoline, kerosene, jet fuel, diesel, oil, fuel oil, etc. Often results in the release of organic and ecological damaging. So see this diagram. So this is a fossil fuel processing and its environmental consequence. So it produces huge amount of SO2, NO2, which is the reason for acid raining. Also, it will produce CO2. That is the main reason for global warming. So we cannot easily get fossil fuel. So the production of a fossil fuel pollute the environment a huge amount. Also, the usage of fossil fuel also pollute the environment. So here, effect of fossil fuel combustion. Fossil fuels are hydrocarbons containing some amount of nitrogen, sulfur, and other elements. So when the combustion occurs, it produces CO2, CO, H2O, NOx, SO2, and HC, hydrocarbon, plus some particulate matter. So here, except H2O, all the other terms are harmful to environment. So only H2 is not environment pollution. CO and many H's are toxic to humans. Carbon monoxide and hydrocarbons are toxic to humans. So when there will be the power plant which releases the HC and CO, it is toxic to humans. Similarly, SO2 and NO2 combine with rainwater to form nitric and sulfuric acid. That is called acid rain. CO2 is the primarily reason in global warming. Important combustion process. The three most important combustion process for energy production are natural gas flames for heating furnace, water heater, boiler flames, and internal combustion engine flames. So burning natural gas for heating produce some NOx, significant CO2, but less than coal or oil. So boiler combustion of coal and fuel air for industrial and electric power produces significant quantities of CO2, NOx, and SO2. Carbon dioxide, NOx, nitrogen oxide, and sulfuric oxide. Because boiler flames are at relatively low temperature compared to IC engines. Most NOx is formed from oxidation of fuel nitrogen. IC engine flames are very hot, which leads to dissociation of N2 and O2. Most NOx in engines is formed from the oxidation of nitrogen introduced with the combustion air. IC engines are also significant producers of CO2, CO, and SO. It is petrol engine, it produces huge amount of CO2 and CO. And if it is a diesel engine, it produces a huge amount of hydrocarbon, that is HC, and SO2, sulfur oxide. Now, environmental impact. So, significant impact for production and exploration, processing, and also final use. So, when the resources are taken from the underground and utilization, that is final use. From the starting to end point, it pollute the environment. Now, environmental impact of oil and gas. So first one, land disturbance. So access and drilling. Byproduct, maybe some oil or gas mixed with water, so waste disposal, so, loads of fires at oil and gas wells. So if fire accident happens, it will take minimum 1 week to sometimes for a huge amount of or a large place natural mining, it required some years and acid mine. So these are the environmental effect of using oil and gas. Now potential impact of considering different renewable energy sources. So we have discussed coal, natural gas, and oil. So these are the non-renewable energy sources which pollute the environment, during its production as well as its operation. Now, different types of renewable energy sources, how it impact the environment. Fossil fuels, that is coal, oil, and natural gas, pollute the environment more than renewable energy sources measurement, including air, water, public health, wildlife, water use, land use, and global warming emission. So types of environmental impact. First one, air. Second one, water, land, wildlife, human health. First, air. Greenhouse gas emission, acid rain, ozone layer depletion, fine particulates, that is SOx, NOx, Hg, water, consumption and pollution, land, on-site and off-site, human health, direct effect, increased risk of illness and increased risk of cancer. Impact from solar power. So these are some images of solar power. So this one is tower power plant. In tower power plant, mirrors are attached at the ground. The large tower focusing point will be there. So here it is produced steam, but the installation cost of this type of power plant is a huge amount of money is required. So this one is PV power plant. Which is attached at the top of the building. So this one is also PV power plant. It is integrated with I think it is at ground surface. It is also PV power plant. It is inside some agricultural land. So first one, air pollution. So while considering greenhouse gas, so during its operation, no greenhouse gas from solar power generation. You consider both PV as well as thermal power plant, photovoltaic as well as thermal power plant. No greenhouse gas from solar power generation, but some from manufacturing, material transportation, installation, maintenance, and decommissioning. That is life cycle emission. It does not pollute the environment during its power production, but when it's manufacturing, it requires a huge amount of energy for manufacturing solar panels, glass, stand. Also, some materials, transportation required from one country to another country, one state to another state. For example, I think China is the largest PV manufacturer. They have fabricated their PV cells and PV panels, and they have transport to the other countries. So during the transportation, huge amount of air will be polluted. During the installation, we have to use some machinery. It will pollute the environment. Maintenance and decommissioning is also require some maintenance. So during its operation, there should be no air pollution, but manufacturing, material transportation, installation records, during this stage, some air will be polluted. So here see the comparison. PV produced 0.18 pounds of CO2 equivalent per kilowatt hour, whereas Coal thermal power plant, it produced 3.6. Here it is 0.18. Is less than 0.1. Whereas in coal thermal power plant, it produced 3.6. Similarly, concentrating solar power, it is 0.2. It is 0.2. So as compared to PV, concentrating solar power produced higher amount of CO2 equivalent per kilowatt of power produced. For coal thermal, it is 3.6. Water. Now, water pollution. PV panels do not use water in the production of electricity like any manufacturing process. So during operation, it cannot pollute the water. But manufacturing process, some water is used to produce the panel. Thin film PV panels use rare earth metals which are mined in China, where stronger regulations are needed to protect water and wildlife. So the material which is taken from the earth, which need some stronger regulation in order to prevent the water and the wildlife. Concentrating solar power with wet cooling requires large amount of water like other thermal generators. So like coal thermal power plant and nuclear power plant, concentrating solar power required large amount of water. Land. Solar power plants use a large area for collection of energy and thus may interfere with existing land uses and can impact the use of areas such as wilderness or entertaining management area. As energy system may impact land through material exploration, extraction, manufacturing, and disposal, energy footprints can become incrementally high. The construction of solar on vast area land imposes clearing and grading, resulting in soil compaction, alteration of drainage system, and increased erosion. So these are some disadvantages of solar PV. Wildlife, environment disturbance and destruction. Human health, none. So during operation, it does not create any pollution. Impact from wind power. So for manufacturing wind turbine, we required some metals. So this is, so the manufacturing process will pollute the air pollution. So for fewer greenhouse gas emission than from coal or other fossil fuels, no greenhouse gas from wind power generation. Only during the material production, it pollute the air. But some from manufacturing, material transportation material has to transfer from one place to another place. On-site construction, during the construction, we have to drill the earth surface and we have to use some building material, concrete structure to form the wind power. So these will pollute the air pollution. That is the same case, the decommissioning and electric commissioning. So as compared to PV, the CO2 equivalent per kilowatt power of wind power is very many. So I think in PV we have seen 0.18, whereas here it is 0.04. 0.04. It is very less. 0.04.
Hello, Prop.
We
can go for 10-minute break.
equivalent per kilowatt. 10 minutes. Oh, okay, Professor. Thank you.
Okay, we'll back around 10:20. Okay.
Okay, okay. Thank you. Hello, sir.
Hello, doctor. You can start now.
Hello, sir.
Yes, doctor, you can start now.
Yeah, I will start, sir. So here, the COT equivalent per kilowatt power for wind power generation is minimum, that is 0.01, whereas in PV it is 0.18. In concentrating PV it is 0.2 pounds, whereas in coal thermal power plant it is 3.6 pounds. Water, wind power requires no water in operation of turbine. So here turbine plates are rotated by using flow of wind from one place to another place. Some water is used to manufacturing, that is steel and cement for turbine. So concrete structure is required for installing the turbine plates. So the extremely small amount of water used in the life cycle of producing wind power is considered a massive benefit. So while considering water, so here the wind power is a minimum consumption of water. So some neodymium and dysprosium are used in turbine magnet. Most are required some water. So land, use large amount of land, that is 30 to 140 acres per megawatt. 30 to 140 acres per megawatt. However, 1 acre per megawatt is permanently disturbed. So for producing megawatt power plant, 1 acre is disturbed, and less than 3.5 acres per megawatt is temporarily disturbed during construction. So these are the about land. And while considering wildlife, bats can be killed while colliding with turbine blades. So continuously huge size blades will be running. Huge amount of huge size blades should be running while the operation of turbine. So it produces environmental destruction and harm animals and the ecosystem. So human health, it cannot directly affect human health, but produce some sound energy. So if you live near to any wind turbine power plant, it may be some little bit harness to the people. So now we will see impact from hydropower. Hydropower. So see this. This is the hydropower. This one is the dam. So here dam store gets open. The continuously water will be flowing. So I think this one is a runoff power plant. So here there will be no dam. Simply so water will be flowing so that the flow of water is converted into kinetic energy. So kinetic energy is converted into mechanical power. Mechanical power is converted into electrical energy. So greenhouse gas emitted during installation and dismantling of power plants. So during the operation, there will be no air pollution, but during installation and the dismantling of power plant, it will pollute the environment. So small run of the river plants emits 0.012 to 0.03. I think wind is 0.04 pounds, PV is 0.18, concentrated PV is 0.2. So as compared to other types, hydropower pollute only minimum amount of CO2 equivalent per kilowatt power. So see here, it is 0.03 pounds CO2 equivalent per kilowatt hour. So when comparing coal thermal power plant, it is 3.6 pounds of CO2 equivalent per kilowatt hour power production. So large dammed hydro plants in semi-arid areas emits 0.06 pounds CO2 equivalent per kilowatt hour. The area of power plant is large size, then it is 0.06. When land is flooded, the vegetation and the soil decomposes and release CO2 and CH4 methane gas. So the greenhouse gas emission depend on site-specific qualities of land. Tropical and peatland areas will release more greenhouse gas. So large dammed reservoir hydro plants emits 0.5 pounds CO2 equivalent per kilowatt hour. Impact of hydro power plant, water. So hydropower plant fully depends on water. We'll do the site selection procedure for hydrothermal power plant, hydropower plant. So the main important point we have to notice is availability of rainfall. So the water, which is a main resource for hydropower, the very first site selection point, the annual average rainfall at the particular location. So this is one of the major parameters we have to consider. So reservoir water is often more stagnant than normal flowing water. Therefore, it has higher amount of sediments and nutrients which can cause too much algae which will form in the water resource. So it will pollute the water resource. So water in reservoirs evaporates more than water in flowing rivers. So if water is stored in the dam, it can easily evaporate than the water in flowing rivers. If water is flowing continuously, it cannot easily gets heated and it cannot easily evaporate. So this is the main parameter. So reservoir operates leads water at certain times to prevent the downstream river level from beginning too low. If operator waits for too long, then the animals and the plants which can be harmed and be killed. So when the dam gates get opened, in some time pieces can be coming towards the penstoke and it will collide at turbine plates so that it cannot live easily. So Fishes are formed during the operation of wind power. See, not wind, hydropower. So now land size of the reservoir created by the project varies widely. So based on the project size and availability of water, so the land size may be varying. So plants in flat terrain require much more land than those in steep terrain, whereas reservoirs can hold more water in a smaller space. So in some cases, they can build the runoff river power plant. It does not require any dam which have to store the water. So simply in the runoff power plant, water can be continuously flowing. So the flow of water can be converted into kinetic energy to mechanical energy, to electrical energy. So flooding on area for a large dam can destroy forest, wildlife habitat, agricultural land, and also some recreational land. Wildlife. Fish and other animals can be injured and killed by turbine blades. So already I informed, fish and other animals can be injured when the dam gates get open. So some animals and the fishes can be jump through the penstock, and through the penstock it will reach the turbine blades. For the turbine blades, there is a chances for fish and animals may become injured, or it may be killed by the turbine blades. So now bioenergy, first one, air greenhouse gas emission would be close to zero, because growing plants represent the CO2 released up to burning biomass. So here we can consider the plants can capture the CO2. Plants can capture the CO2. So the amount of CO2 released by the fossil fuels vehicles and the power plants can be captured by the plants. So here it is mentioned the capturing amount is equal to when releasing. So they have called as zero greenhouse emission. The major cause of indoor pollution making biomass burning a leading cause of child mortality. Emission generated during the feedstock production phase include vehicle emission, diesel emission from large equipment, emission from storage, dispensing of fuels, and test. The level of emission would vary with the scale of operation and may be greater for agriculture operation and forestry operation. Water. So the use of pesticides and fertilizer to enhance feedstock and also damage water quality. So for and nowadays all the agriculture people use the pesticides and fertilizers to enhance the feedstock. That is, for example, if corn is a biogas bio material, then they have used fertilizer to enhance their feedstock. So it can damage the water quality, land. Feedstock production is the cultivation of crops such as corn, soya beans, or any grasses, and the collection of grape residues from and woody residues from forest. So this required huge amount of land for cultivation. Wildlife. So planting crops on pristine land or cutting down or banning forests destroyed wildlife habitat. We can plant the more number of plants in particular land, and once it reaches the maximum level, then we have to destroy the everything, and we have to use it to produce the biomass. So this is the wildlife affection. So human health. So so planting plants for biofuels on using land, fertilizer, and energy that could otherwise be used to grow food can lead to food shortage and increase the prices for wood. If you used the corn for biogas, then the food price may be increased. So human will be affected. Renewable energy resources and their importance. Renewable resources refer to the source of unlimited natural energy that does not face the threat of depletion from overuse. Natural elements such as wind, sun, and that is a sea, water resource. Sources are renewable energy. Today, the world is facing a major energy crisis. So, I think the major war which happened at Iran, Iraq, Syria, Libya, the reason is conventional energy sources, that is coal, natural gas, and oil. So the also in some country they don't have the technology for extracting the natural resource, but some developed countries use their technology and they have taken their oil resource, their gas resource, and fixed their price. So the war which happened due to the natural resources. The quantity of fossil fuels has dipped dangerously low from mass and arbitrary usage, which means that more and more people being forced to move to the most sustainable energy source. It may be solar, wind, or hydro. In fact, sustainability perhaps the wealth that can best sum up the important question that renewable energy sources have in the current world. With rising prices of fossil fuels, it would soon become impossible to live with the other sources. So some developed country fixed the fossil fuel price. So we have to depend on others. In India, we have nuclear power plant. We have got some agreement with the United States. So we are fully depends on United States for uranium fuel. Also, we don't have some recycling techniques. For recycling techniques also, we have to depend with the United States and Russia. So these are the some major drawbacks in a natural resource. That is a conventional resource: coal, nuclear, natural gas, oil. Some places we have to depend on developed countries, whereas in some cases, developed countries did some political or what I say. Some game like they have created fight between two countries, for example Iran and Iraq. The reason behind the war is the natural resource, that is gas and oil. So also if you use sun, water and wind, so it is available abundance in the unlimited quantities across the world. So the cost of using them is falling at a highly competitive rate. It is easier for all people to make use of renewable energy, given that the cost of producing its minimum cost. Also, it is a clean energy. Biggest advantage is a very, very clean energy. It does not pollute any CO2, SO2, NO2, CO, HO. It is a fully pure form of energy. Cannot pollute environment. Does not produce any greenhouse gases that are highly harmful to the environment. Global warming has become a very real threat to the world right now, with increasing temperature across the world and severely threatened climates and ecosystem. So if you use PV power plant, wind power plant, it does not produce any CO2, so that the global warming level can be decreased. So next. Inaccessible source. So the sun is a source of renewable energy, that is both the solar PV and the solar thermal, which makes it an inexhaustible resource. We will be able to get resource to create clean energy as long as the sun is there, which makes sense. The same goes for all other types of renewable energy, such as geothermal energy, tidal energy, hydraulic energy, biodiesel energy. These energy resources are naturally available, all constantly being part of the earth mechanism, unlike fossil fuel and uranium, which are finite resources. Finite resources means after some years, we cannot get it back. Fossil fuels, petrol, gas, coal, these kind of things, we cannot get it in future. Next, very important one is public health. So if you see the operation of a nuclear power plant, let us consider some accident. Then what will happen? For example, around 50 kilometers radius, people cannot live for 100 to 200 years. After 100 to 200 years also, the nuclear radiation will be comes in that area. So it will harmful for human as well as humans. So this is the very important parameter, public health. Also consider coal thermal power plant. In coal thermal power plant, it releases the CO2 and SO2. It is harmful for humans. So continuously, if anyone living near to coal thermal power plant, they may have asthma, and sometimes they may have cancer. So these are the public health. Whereas if you build the solar panel, it cannot harm public health. It does not emit any pollution like CO2, NO2, SO2, carbon, CO, any particulate matter. It doesn't produce any environmentally polluted component. So renewable energy barely poses any such threats to the health of the peoples and animals. Very little water is required to harness such source, which makes non-renewable energy the least contributor to water pollution. Next, economic benefit. So if you let us consider my country, if I am running in my country running a nuclear power plant, they have to purchase nuclear material from the either Russia, US, or they have to get it from Australia. So the reason is Australia have maximum nuclear resource. Also Russia and US, they have also maximum nuclear resource. So we have to purchase it from others. Whereas if you consider that is the fuel cost, that is running cost, it depends on the fuel cost. Whereas if you consider solar thermal power plant, first we have to erect the power plant. So the resource is fully free. The operation does not require any coal or any uranium. It's fully depends on concentrated PV. So the way of the concentrating collector or concentrators, which is used to produce the hot water, it is the main source. So apart from being a much cheaper resource, the renewable energy industry also employs a vast number of people, potentially more than non-renewable energy department. This is mainly because of the fact that renewable energy is more labor intensive, unlike non-renewable energy, which is highly mechanized process. Apart from the direct employment of laborers in areas like turbine installation, maintenance, planning, and logistics, indirect employment is also huge. More and more automotive companies are shifting to the production of electric vehicle. More resilient source. Renewable energy sources require distributed and modular system, which makes them less susceptible to large-scale disturbance. Because of the modular system, which consists of a number of equipment working by themselves, we do not run the risk of being left off without power because of the failure of system. If there is any disturbance in any one geographical area leading to equipment damage, the rest of the equipment will continue to produce energy. Let us consider two power plants. First one is solar PV and the second one is coal thermal power plant. If any accident will happen, coal thermal power plant has to be shut down and it has to be rectified. Then only we can produce electrical power. And another case is solar PV. If any small panel or small module has some mistake means, or it does not produce electrical power means, other system can produce electrical power. So continuously it can produce power without any disturbance. So now we will see about different types of collectors which can be used for producing hot water as well as it is used for producing the steam. So first, it is broadly classified into two types. First one, non-concentrating collectors. Second one, concentrating collectors. Non-concentrating collector means it does not continuously require talking. Simply, we can uh, place it at the ground surface. I think its collection factor is 1. The example for non-concentrating collectors are flat plate collector and evacuated tube collector. Flat plate collector and evacuated tube collector. It is used for producing hot water. Concentrating collector is it concentrates solar energy at particular line or particular point, so that it is called concentrating collectors. It is used for producing hot water as well as steam. First one, CPC, is compound parabolic concentrator. Second one, parabolic disc collector. Third one, parabolic trough collector. And the fourth one, solar power concept. So these are the some important concentrating collectors. So in this concentrator, we can use some energy storage material. Here, molten salt is available for store the heat energy. And whenever there will not be heat energy is not available, we can replace the stored heat energy. This is the schematic view of flat plate collector, and this is the schematic view of evaporator tube collectors. So see here. So at the top, cover is, that is a cover means a collector cover. So it can be a transparent material. It should be a transparent material, so that the amount of heat energy which is received on this collector surface is passed through the absorber plate. As well as here they have used float tubes. In the absorber plate, they have attached float tubes. So absorber plate, usually black chrome absorber coating to maximum heat collector HCMC. So here it should be an inlet connection. Inlet means here water should be flows inside the tube, and once it will flows through this tube, what will happen? It will continuously receive the solar energy, that is the heat energy from the sun. Also, some amount of heat energy is stored at the absorber plate. Absorber plate, so that the heat is transferred from absorber plate to flowing water. Also, tube continuously receives solar energy from the sun, so that water become hot, and hot water can be produced. So this is the simple form of flat plate collector. So here at the bottom of flat plate collector, we must use insulating material. If we didn't use insulating material, 20% of heat energy should be losses to the ambient, that is to environment. So in order to prevent that 20% heat, the flat plate collector basin should be insulated by using low cost insulating or low thermal conductivity insulating material. Commonly, thermocol has been used as insulating material for this type of application. Now, evacuated tube collector. In evacuated tube collector, evacuated tube is used to arrange the flow path diagram, flow path. So here, copper tube is used. Here, instead of copper tube, evacuated tube can be used. So here, hot water is flowing from here, and it will move towards the upward direction due to the density, due to the higher density. Once it will become hot, it will easily move to the top layer of this tube, so that we can produce hot water. In some cases, it may produce a small amount of steam also. So these are the main two non-concentrating collector: flat plate collector and evacuated tube collector. So here there are 4 different concentrator. So these two are line concentrator. These two are line concentrator. These two are point focusing collector. So first one, parabolic trough collector. Parabolic trough collector. Here it is observer tube. Here it is observer tube. It is the observer. This is a collector. This one is observer. So when sunlight falls on the observer, that is a collector, the incident solar radiation will passes through this observer tube. Similarly, tube also receives the heat energy, so that the steam is produced, so that the steam is produced and it can continuously flowing. And here turbine will be there in the same operation. Turbine blades should runs, and here kinetic energy of steam is converted into mechanical energy. Mechanical energy is converted into electrical energy by placing generator that is coupled to turbine. So this is the working principle of parabolic trough collector. So it can produce up to 200 to 400 degrees Celsius parabolic trough collector. And the second one is linear Fresnel reflector. So the same, instead of here observer plate, here curved mirrors are placed at the ground. Curved mirrors are placed at the ground. It is a line focusing. In this line, heat energy is focusing. So observer tube and reconcentrator. Here heat energy is reconcentrator. So here it will falls, and it should focus at this point. Similarly, here solar intensity will fall. This will focus here. Once again, the same water is flowing. So that it will get heated. So the heated water is stored in the turbine. So these are the first two types. This one is a tower type. Tower type. So here, solar receiver. It is called a heliostat. It is used to install. Okay, here sun intensity will focus at this point. So the amount of heat energy which receives on heliostats will be focused onto the this place. So again the same process. This one is parabolic disc collector. So here also this is a point focusing. It is called receiver. It is called reflector. See the amount of solar intensity which receives on the solar disk can be focused on this point receiver. So already I told some introduction about solar thermal. So in solar energy, there are two types. First one, solar PV and solar thermal. Solar PV means light energy to electrical power. Solar thermal means heat energy to power. In cold climatic area, the amount of local energy is used. So 25% of all industry application consumed for heating fluid to moderate temperature. Solar energy for preheating up to 180 degrees Celsius. Solar thermal collector, so low density per unit area, collected by covering large area, solar energy as a heat transferred to heat transfer fluid. So here heat transfer fluid, some researchers used some pi fluid, that is nanoparticle mixed with water, so that the thermal conductivity of water should be increased, so that it can be easily get the heat energy, and the heat energy can be converted into steam. Now thermal storage and heat exchanger. So already we have seen non-concentrating, concentrating, focus type, point focus, non-focus. In focus type, cylindrical parabolic concentrator. It is a line focus, fixed mirror solar concentrator, linear Fresnel lens, point focus, parabolic disc collector, hemispherical bowl mirror concentrator, circular Fresnel lens collector, central tower receiver. In non-focus, modified flat plate collector, common parabolic concentrating collector. So these are the different types of concentrating tanks. So now, how to do the performance calculation? So for performance calculation, we have to calculate collector efficiency, concentration ratio, and temperature range. So collector efficiency. So the ratio of energy actually absorbed and transferred to the heat transport fluid by the collector to the energy incident on the collector. For example, let us consider 1000 watt per meter square receiving from the sun to the earth, and it received maybe 800 watts energy by the observer, and we have to check how much heat is transferred to the fluid. It is called collector efficiency. And the second one, concentration ratio. Ratio of the area of aperture of the system to the area of the receiver. The concentration ratio for non-concentrating collector should be 1. The ratio of area of aperture of the system to the area of the receiver is called concentration ratio. Aperture of the system is the projected area of the collector facing the beam. Temperature range of temperature to which the heat transfer fluid is heated up by the collector. For example, 0 to 70 degrees Celsius and 0 to 100 degrees Celsius. So this is the temperature range. Now non-concentrating collector. So absorb radiation received on surface. So the main advantage of non-concentrating collector is it receives both beam and diffused radiation. It received both beam and diffused radiation. No optical concentrating method. It does not require any tracking. We can simply install the flat plate collector over the ground surface. No need of solar tracking. So while installing your PV system, your latitude, for example, your latitude is 20 degree means you should install your PV as well as non-concentrating system at angle equal to latitude of your particular place. Here, if it is 20 means the angle should be 20 degree. No need of solar tracking. Simple and compact construction. Fixed on rigid platform. Maintenance free. High temperature cannot be achieved. So the main disadvantage is we can getting up to 70 degrees Celsius. Now concentrating type. So converging solar radiation from large area to small area. So you can see parabolic absorber and the top should be absorber tube. Similarly, parabolic disc collector, and the top should be small receiver. Linear Fresnel lens, and the top should be small receiver. So here, solar intensity is converging from large area to small area. It may be either a line or it may be a point. So beam radiation is utilized. So optical methods, so reflection and refraction should be depends for performance improvement. And another one is solar rays tracking is required. So for better operation of concentrating type collector, solar tracking is required. Diffused radiation cannot be concentrated. High temperature attained. Flexible construction. So this is the schematic of flat plate collector. It can produce the hot water. The temperature range may be less than 100 degrees Celsius. It can replace both beam and diffused radiation. So see this schematic. So here it is the absorber tube. Here it is the basin material. It is collector cover material. That is a transparent cover. Here it should be a thermal insulating, that is insulating material. We can use either low thermal conductivity material or like thermocol. Some cases, some nylon particle also can be used as insulating material. Even some researchers used composite material as insulating material for flat plate collector operation. So it can produce less than 100 degrees Celsius. The operation is very simple. So when water tank is there, so when water is flowing inside the tube, so heat is extracted by the working fluid, water, that is water. Heat is extracted by working fluid. So here maybe the basin temperature is 60 to 80 degrees Celsius and the absorber tube temperature is 70 to 80 degrees Celsius. When 30-degree water is flowing through the tube, what will happen? The amount of heat energy which is available at the absorber plate and the tube can be converted into water. The heat which is lost from the absorber plate is equal to heat gained by the water. Heat gained by the water. So it is the working of flat plate collector. A flat plate collector is basically a black surface that is placed at a convenient path of the pan. And a typical flat plate collector is a metal box with a glass or plastic cover that is called glassing on top and a dark colored absorber plate on the bottom. The sides and the bottom of the collector are usually insulated to minimize heat losses. So insulation is very important. So we have to insulating the basin surface so that the heat losses should be minimum. So now components. First one, absorber plate. It is usually made of copper, steel, or any aluminum material. The surface is covered with a flat material of for high absorption. So it should be a flat material so that the maximum heat energy should be absorbed by the material. If copper or steel is used, it is possible to apply a selective coating. That is nothing but black painted. Copper or steel could be black painted so that it can receive maximum solar energy and minimizes the radiation emitted by plate. Now, flow passages. The flow passages conduct the working fluid through the collector. If the working fluid is a liquid, the flow passages usually tube that is attached to or is a part of the absorber plate. So over the absorber plate, copper tubes or aluminum tubes are placed. If the working plate is here, then flow passage should be the absorber plate to minimize the heat loss. So cover plate should be high transmittivity material. Cover plate, it should be high transmittivity material. So it covers are generally placed above the absorber plate. They usually be made of glass or any plastic. So transparent glass or any plastic material. Next, insulation. There are some materials such as fiberglass, and they are placed at the back and the side of the collector to reduce heat losses. Thermocol is the best low-cost insulating material. Thermocol can be used as insulating material. Bottom of flat plate collector and the side walls should be insulated. Now a box that is the collector is enclosed and holds the components together, protect from the weather, facilitate the installation of the collector on a roof or appropriate frame. It's called enclosure. So see this diagram. So cold fluid in and warm fluid out. Cold fluid in and warm fluid out. So this is the energy conversion process or energy flow diagram. So see here, sun produced both direct radiation and diffused radiation. If the amount of solar intensity which is received is does not affected by clouds, it is called direct radiation. If it is affected by cloud, then it is called diffuse radiation. Once it will reach the collector surface, the some amount of intensity that is around 20% or 10%, I think 10% is reflected back to the RP, and it is called as loss. And some amount of heat energy should be entering into the absorber tube and then flow of working fluid. After it reach absorber tube, some material is sent back to the heat energy lost to the ambient. Also, some is transfer from basin material to air, that is a convection heat loss. So it will also happen at flat plate collector operation. So cover plate. So selection of cover plate. So selection of absorber plate. So first one, it should be high absorptivity material. Absorber plate should be absorb more heat energy. Similarly, it should be high thermal conductivity material. It should be high compressive strength, good corrosion resistance, less specific heat, easily workable, easy to handle, low cost. Example, copper, aluminum, and steel. It should be a low cost material. I think steel is a low cost material as compared to aluminum and copper. Next, cover plate. So cover plate should minimize convection losses. Minimize radiation loss also. It also should be a hood strength, durability, non-degradability, efficient solar energy transmission, rigidity, resistance to thermal shock. So insulating material, it provided the back of absorber and the side of the walls to reduce conduction losses and to maximize the efficiency. Usually made of polyurethane foam or mineral wool. So mineral fiber material like glass wool, rock wool, glass fiber, or fiberglass. So application of flat plate collectors, it can be used in both domestic and commercial application. In commercial application means we can use flat plate collector for heating the swimming pool water. Domestic means our day-to life, we can use as a water heater. So see this building. So this is solar collector. So here huge amount of solar intensity has collected here. And if I use the blower and we can send the air to cool, or we can use water. So this one also building integrated PV. So here flat plate collector can be used to heat the swimming pool water. So that temperature level is here minimum. Now evacuated tube collector. So this is inflow. Here it should be outflow, evacuated tube, glassing, reflector. So in between the evacuated tube collector, reflector are placed so that the amount of heat can be reflected. So these are the losses. So losses on glass surface, losses on absorber plate. The heat loss through the rear and the side walls. So this one is modified flat plate collector. Just The main difference is here external mirrors are attached. External mirrors are attached. Two external mirrors are attached. When sun is here, so that the amount of solar intensity which received on this layer should be enhanced by using reflecting material. Similarly, when the sun is moves from morning to afternoon, so here maybe sun will be there, so that here one reflector is there, so it can focus the solar intensity at the base of the collector. This one is a compound parabolic concentrator. So this one is non-concentrating collector. So here aperture area, that is focus of parabolic A. So this section of parabola A is used to focus sunlight here. Similarly, this focus of parabola B is used to focus sunlight here. Sir, can I take 5 minutes break, sir?
Yes, sir. Yes, sure.
Thank you, sir.
After 5 minutes, you can start again. No problem.
Professor, can I start?
Yes, Prof. You can start.
Okay. So this is the semantic view of parabolic concentrator. So here we can use either glass or stainless steel material. So this is the collector. So this is the collector. Here solar intensity will be collected and it will be reflected back to the receiver. So this is the line focus. So here we can flow the water. So this type of concentrator, it required continuous tracking. It requires continuous tracking for achieving maximum efficiency. If you employed mirror, its optical reflectivity should be 95%, whereas if you employed stainless steel, it may be 80 to 85%. So the best one is mirror. So we can employ the mirror. So when the solar intensity is falling on the mirror, it will focus at the receiver surface. It is focused at the receiver surface so that water will get more heat energy. Water will get more heat energy as compared to non-concentrating collector, that is parabolic plate collector. Here the temperature is almost double. It can produce up to 150 to 400 degrees Celsius. So this is the photographic view. So this is the collector surface. This is the receiver surface. During the morning time, if the sun is rises here, we should keep this direction. Once it will reach us towards here, then it may be, we have to track this one to the perpendicular, not perpendicular, it should be to adjacent to ground surface. And once it reaches here, then it should track to this place should be comes here. So like this direction, so that it can get maximum solar intensity. So this is the working of cylindrical parabolic concentrator. This one is a special type, that is a fixed mirror solar concentrator. So here mirrors are fixed, here point focus. So the amount of solar intensity which will receive here, so it will continuously heated up. So this one is a linear Fresnel lens concentrator. So here at ground surface mirrors are attached. Here line is there. This one is a parabolic disc collector. So this one is reflector surface. Here it should be a receiver. This is a supporting structure. Here fluid should be processed here. So this one is a photographic view. So this one is a receiver, rubber plate. So this is a tower concept. So it is located at California, USA. This one is the world largest central tower power plant. So here heliostat, so small amount of mirrors are attached at the ground surface. So here it is a focus point. So here water will be flowing and it can produce the steam, and the steam is replaced for producing the electrical power. So how we can calculate the performance of particular collector? So here A is the surface area of collector, IC is solar input, FR is a heat removal factor, tau into alpha is effective product of transmittivity, that is the tau is the transparent cover, and absorptivity alpha, UC overall heat loss coefficient, T in fluid in temperature, TA ambient temperature. Here we can use this formula. QC is equal to A into IC into FR. So IC is the collector cover, A is the area, tau into alpha, that is the transmittivity, FR is the heat removal factor, and UC is overall heat loss coefficient, T in minus TA. T in is inlet water temperature and TA is ambient temperature. So yeah, effective optical efficiency is equal to FR into tau alpha into E. Effective overall heat loss coefficient FR into UC. Now efficiency is equal to useful heat divided by incident solar energy flux. That is QC divided by A into IC. A is area of collector, IC is solar intensity. Efficiency is equal to useful heat gain. So for let us consider one flat plate collector. So it may produce the hot water of 70 degrees Celsius continuously. So we have to calculate efficiency. How we can calculate? We have to substitute area, incident solar radiation, and useful heat gain QC. So here it is useful heat gain. So once you substitute useful heat gain and the incident solar intensity, we can get efficiency of solar collector. So for solar water heater, for swimming pool, the temperature range can be 23 to 28 degrees Celsius. Domestic hot water, 45 to 60 degrees Celsius. Space heating, 30 to 90 degrees Celsius. So maximum for the heating swimming pool, flat plate collector is used. So the same, it is flat plate water heater. For 2 minutes, I have received one call. So this is the passive solar water heating system. So here evacuated tubes are attached. So these are the evacuated tubes. So here water will be inletted here. So due to the density, it will flows up, and here we can get the hot water storage tank. Here water should be stored, and whenever we can use, we can get hot water. So this one is flat plate collector. So here we can replace the evacuated tube collector. Here one copper tube is placed in between a collector cover and absorber plate. So the main difference between FPC and ETC is, so in ETC, vacuum tubes are used. Since its density is very minimum and the pressure is very minimum, it can easily heat it up. Whereas here copper tubes are used. This one is active system. So in active system, some pump is used to flow the water. So see here pump is used. So this one is a controller, here solar collector. So this is called active system. So we have seen a concentrating collector, that's the parabolic trough collector, central receiver with the heliostat field, parabolic disc concentrator, Fresnel lens concentrator. So these are the main concentrator. So concentrating or focusing collectors intercept direct radiation over a large area into a small observer place, from the large area to small observer plate. So these collectors can provide high temperature more efficiently than flat plate collector. So the reason is, in flat plate collector, the concentration ratio is 1. Concentration ratio is 1. Whereas in non-concentrating collector, the concentration ratio may be varying. So based on the design, it may be varying. Also, flat plate collector, it does not require any tracking mechanism. Whereas a concentrating collector, we can employ some tracking techniques so that we can achieve maximum water temperature. We can achieve maximum water temperature. So most concentrating collector require mechanical equipment that constantly orients the collector towards the sun and keeps the observer at the point of focus. Therefore, there are many types of concentrating collector. Parabolic discover. So already we have seen this parabolic trough collector. So here it is concentrating reflector. So during the winter time, it may be placed like that so that it can receive maximum solar energy. So when you plan to install solar devices like non-concentrating devices, you must install it at angle equal to latitude angle. For example, here my latitude angle is around 11 degree. So I must keep the collector's area 11 degree. So two types of axis is required. First one is single axis and second one is dual axis tracking. So this is the parabolic trough combined with gas turbine. Parabolic trough combined with gas turbine. So two types of system are combined. This one is parabolic disc collector. So these are the some collector surface. Here it should be a receiver surface. So it uses a dual axis sun tracking. Dual axis sun tracking. This is also parabolic disc system. It can reach up to 1000 degrees Celsius. It can reach up to 1000 degrees Celsius. It can use it to produce electrical power. It can produce steam. Steam is used to run the turbine. The turbine is coupled to generator to produce electrical power. So several prototype disc engine system ranging in size from 7 to 25 kilowatt have been developed in various locations in USA. So in 1984, the system is erected. It is at operation. Its net efficiency is around 29%. So this is the heliostat. So here heliostats are attached. That is the reflecting mirror. Here it should be receiver. So here these can be tracked. For example, when sun is moves from east to west, it can be tracking, and that focused solar intensity will be received here. So it can also reach 1000 degrees Celsius. So this is the photographic view of parabolic disc collector. So it can produce 25 kilowatt power. This system can be combined with natural gas and resulting in hybrid continuous power generation. So the main disadvantage of these type of solar concentrator is when there will be no heat energy from the sun during the winter season, it cannot produce electrical power. So at that time, this type of system can be combined with natural gas so that it can provide hybrid continuous power generation. So this one is a tower concept. The tower concept reach up to 550 degrees Celsius. This is the receiver. This is a heliostat. Here a number of heliostat will be attached so that the solar intensity which receives from heliostat will be focused at a receiver point. Here some salt storage. Here salt can be employed to store, and the heat energy which is received on receiver can be connected to hot storage medium, so that whenever the sun is not available or when it's low intensity, the stored salt energy can be placed to produce the mechanical power, and this mechanical power is converted into turbine generator set to produce electrical power. So commonly used energy storage material is molten salt storage. So now technology comparison. Parabolic trough, this and power tower. So it can parabolic trough, it can produce up to 320 megawatt. I think the parabolic trough is producing maximum size. Whereas power tower, it can produce up to 200 megawatts. Diesel engine, it can produce up to 5 to 25 megawatts. And operating temperature is 390. Here this engine is 750. Power tower is 566. Capacity factor 23 to 50, 25, 20 to 77. Peak efficiency is 20%, whereas power tower 23%. Net annual efficiency up to 16%. disengine, it can be up to 25%, power tower up to 20%. So technology developed parabolic trough, low disengine, high power tower, medium. Storage available, limited. In disengine, we can employ the battery. Power tower, we can use molten salt. So cost wise, if you compare this engine, this coupled with engine is high cost. So these are about renewable energy system. Now we sir, my new PPT is visible, sir.
Could you slide share? I think we can see your the computer folder, but we can see slide.
Wait, sir, from beginning. Now, sir.
No, I think you stop sharing and share again.
So now it is visible, sir.
No, I think that you just share your computer screen, but not slide. Now can see, yes, now you can slide share.
Okay, now so already we have
Yes,
discussed about
yes,
what is mean
Doctor.
energy. Yeah. Already we have discussed about what is mean by energy, what are the different types of energy available, what is non-renewable energy, what is renewable energy, what are the advantages of non-renewable energy, and what are the advantages of renewable energy, what are the environmental impact of utilizing non-conventional energy and also renewable energy we have discussed, and we have covered overall about some of the water heating technology. So now two types of power generation is available: solar PV power generation and solar thermal power generation. So now we will see about some importance about solar energy, and we will see the power generation techniques by using solar energy. So the energy that is produced from sun is known as solar energy. So how it produces energy? So the sun's energy comes from nuclear fusion reaction. Nuclear fusion reaction. So in nuclear power plant, they have used nuclear fission reaction. Nuclear fission reaction means it is controllable reaction, whereas nuclear fusion reaction means it is uncontrollable reaction that takes place deep in the sun, where hydrogen nucleus fuse into the helium nucleus. When such reaction takes place, an enormous amount of energy, that is the heat and light energy, is provided, which is escaped into the space. So a sphere of intensity of hot gaseous matter consists of H, hydrogen, helium, oxygen, carbon, neon, barium, and its surface temperature is around 5,800 Kelvin. Its core temperature is, I think, 13 crore or something, 13 crores, 6 lakhs Kelvin. So now, what is meant by solar constant? So it is used for calculating PV performance. The amount of incoming solar radiation per unit area incident on a plane perpendicular to the rate as the distance from the sun to the earth. It is called solar constant. So it is 1350 watt per meter square. So already we have discussed about energy cycle. So these are the important parameters: latitude, altitude, atmospheric transparency, solar zenith angle. It is used for installing the solar product at your place. The optimum angle is equal to your latitude place. If your latitude place is 80 or 70, you have to install your solar panel or any solar devices equal to latitude. In summer, it should be minus 15 degree with respect to your latitude angle. For example, if here 30 means 30 minus 15. 15 is optimum angle. For winter, 30 plus 15. It is optimum latitude angle. So already we have discussed about reserve. That is coal reserve, oil, gas, and uranium. Here it is estimated years. So oil may be around 200 years, coal may be around 40 years, gas may be around 60 years, uranium may be around 35 years. So this is the available period. So after these, maybe around after 200 years, we will not have coal in our earth, oil, gas, and the uranium. So this will be accessed in the nearby future. So we cannot get this future. Now, solar energy, no pollution, inaccessible, will not exhaust, contribute to energy supply and CO2 emission. The annual collector yield of the world was 109,713 gigawatt hour. This corresponds to an oil equivalent of 12.4 million tons and an annual avoidance of 39.4 million tons of CO2. So this is the PV. This is the photovoltaic cell. It consists of P-type material and N-type material, and it forms a p-n junction layer. When electrons which is present in the solar intensity strikes the P layer, electrons will move from P layer to N layer. So the movement of electrons from P to N layer will create a DC EMF. So it produces DC power. Now solar thermal. Solar thermal means already we have seen different types of solar thermal energy conversion process. So we can use it for solar water heated, solar thermal power generation, solar cooling, solar thermal ventilation. So these are the some applications. So apart from this one, solar energy can be used to produce fresh water by using solar distillation method. Water heater can be produced from using different water heating techniques, and cooking. We can use it for solar cooker for cooking. Drying application we can use it for drying also. So see this, these are some techniques which can be employed by using the solar energy. So introduction to photovoltaics. Photovoltaics, it is fully depends on light energy. Light energy. If its temperature increases, its performance it should be decreases. So this is one of the main parameter. It should be working at operating minimum operating temperature. In 18th century, French scientist recognized the photovoltaic effect. In 1883, first solar cell was developed by Charles. He coated semiconductor selenium with an extremely thin layer of coal to form the junction. So semiconductor selenium. Yeah. So nowadays we have used a silicon material. And it is coated with coal to form junction. In 1954, Bell Laboratory, the experiment was conducted and they have produced solar cells with efficiency of 6%. That is sunlight into useful electrical power. In 1958, first spacecraft to use solar panel was US satellite Vanguard-1. So these are the initial invention of the solar cells. So 1950 it is developed, and in 1958 they have used in first spacecraft. So this is very, very important. The amount of solar energy that reaches the Earth's surface every hour is greater than the human total demand for energy in 1 year. So, but we cannot convert all the heat energy and all the light energy which is received on the Earth's surface. But the statement is the amount of solar energy that reaches the Earth's surface every hour. For example, morning 10 to 11 hour. What is sun emits the power, that is heat energy and light energy, it is equal to human need, that is human demand for energy throughout the year. So 1 hour of sun power is equal to throughout the year how much power human require. So this is very important. So this is the photographic view of photo PV panel. Photovoltaic converts light to electricity. It does not depend on heat energy. It depends on light energy. So here it is a silicon material. It is the connection. Sunlight falls on PV material so that DC power should be created. So these are the different installation. So this one is installed at installed in like a street light port. This one is installed at a desert surface. These are the panels. It is also installed at ground surface. This one also installed at ground surface. So free electrons, photons. So it consists of p-type material and n-type material. N-type materials has a electrons as majority carriers. So when moves from n layer, p layer to n layer. So it is PV cell, it is PV module, it is PV arrays. So number of cells connected to form the module, number of modules connected to form the array. So this one is solar energy, it produces power, DC power. So first one is silicon solar cell. It is further classified into single, multi, and thin flame. And recently, organic solar cells, nanomaterial solar cells also used. Single crystalline solar cells, its efficiency is between 16 to 19%. Multi-crystalline solar panel, its efficiency should be in between 14 to 15%. So this one is flexible solar panel. We can bend the flexible solar panel, and we can fabricate at different shapes like a cone or pyramid. So whatever design you want, you can do it by using flexible solar panels. This one is an organic cell and it is a nanostructured cell. But the main problem is its efficiency is less as compared to monocrystalline cells. So these are the nano cells. See here N-type semiconductor material, PN junction, P-type semiconductor material. So the majority carriers of N-type semiconductor material is electrons, P-type semiconductor material is holes. So electrons is go from N-type to P-type to this PN junction. So DC EMF is generated at PN junction. So the same theory here explained. So it is a cell, it is a module. Number of modules are connected to form array. So now this is PV power plant. So this is PV array. Here DC power is generated. So generated PV power is stored in the battery. So this is the battery. In battery, in DC form, it is stored. Here it is a charge controller. So the main purpose of charge controller is it cannot send back the DC power to the PV array. It is used to prevent the send back to the PV array. So DC load. So from the battery, we can use inverter. So the main purpose of inverter is it is used to convert DC to AC, and the AC load we can use it our home. Now grid connected with battery backup. Grid connected with battery backup. So here it is a PV panel. Here it is charge controller. In our utility grid, it is a AC. It is not a DC, but the power generated by using the PV panel is a DC. So this DC is stored in the battery. Here DC is converted into AC by using inverter, and the AC power is used in household applications. Also, we can send it to utility grid. So it is also the same working principle, utility power grid. Grid connected PV system. So see here, this is parabolic trough collector. So here water is flowing so that it will gain heat energy. Also it will receive heat energy from the parabolic trough collector so that the steam is produced. The produced steam is used to run the turbine blades. Turbine blades. So here turbine blades are coupled to generator so that it can produce electricity. So this is the schematic of solar thermal power plant. So already we have seen this type of power plant. Now, different types of power plant. So parabolic trough, its efficiency is 15%. Linear Fresnel receiver, its efficiency is 10%. Tower receiver, it's produced 20 to 35. Parabolic is 25 to this. Parabolic disk 25 to 30%. So here hybrid mode is available for all the power plants. It is installed in Spain. So it is called PS10 and PS20. This is PS10, it is PS20. This is the large tower. So here a receiver will be there. So this one is a collector. So they will focus the light energy at here. This one is a linear Fresnel reflector. So here large DUP is there. So here and this is collector surface. It will focus the intensity of the line focus. This one is also linear Fresnel reflector. It is also installed at Spain. So these are the array of linear Fresnel reflector. It reflects the solar intensity at this line and it produces this steam. We can use instead of coal thermal power plant, we can use this type of power plant. Now application, we can use solar energy for hot water system, district heating, space heating, packet integration, seawater desalination, industrial process heat, solar cooling. So these are the packet integration. So in the roof of our building, we can incorporate solar panel. So it can produce electrical power. We can use it for our home applications. Either we can directly use as a DC application or we can convert into AC for AC application. These are the some installed PV power plants at the roof of building. It is the hot water system. That is a flat plate collector with the storage tank. So these are the figure integration. Here PV panels are integrated. Here also PV panels are integrated. This is balcony integrated. Here PV panels are integrated at balcony of our home. So advantages are clean and sustainable energy, freely available, provide electricity to remote places. So it is very important. In remote places, maybe government not able to give the electricity. So at places, PV is the only solution where we can get electricity. So disadvantages, its efficiency is less and costly. So its reliability depends on location only. So these are the house of future. The future house should be like that. So this is a zero energy house. It was located in Netherlands. There's 30 meters square of PV panels for power generation and 12 meters square of solar collector for water and space heating. Around 40 meters square land is utilized for solar energy harvesting. So 30 meters square for PV panels, 12 meters square solar. Professor?
Yes, bro. So we can go now for lunch break, and after 1 hour, we'll
Okay.
back again.
Okay, sir. Thank you.
Thank you. Bro.
Thank you.
Good afternoon, doctor. Welcome
Good
back
afternoon,
to
Professor.
our second session. So now you can proceed your second session.
Okay, okay, Professor.
Okay.
Second session for 1 hour or it will be for 2
1 hour,
hours,
1
sir?
hour, 1 hour.
Only 1 hour. Okay. Students will attend, Professor?
Yeah, they already joined. So you can start and maybe you can do 45 minutes, then we can go for Q&A, 10 or 15 minutes.
Okay, okay, Professor.
Okay, thank you. We can't see your slide, doctor.
Now it is visible, sir?
No, not yet. It's not open still.
Okay, okay, wait.
Yeah, now we can see, and you do slide share. Okay, we can see your slide.
Okay, good afternoon to all. So, this session we will see how to do a research. How to do a research. So, basic procedure, that is, what are the things you have to do for a research for UG student, PG students, as well as for PhD research. It is common for all. So, first, what is mean by research? Research refers to a search for knowledge. For example, if anyone working in pollution related study, for example, air pollution, then first they should know what is mean by air pollution, what are the chemical composition involved in air pollution, and they should refer latest research article, what is air pollution, how the pollutants can be controlled by using different control techniques. Similarly, if you take solar research, means in solar research there are n types of sub titles are there. For example, water heater, PV, thermal. If you looking for water heater, then you have to what I can say. You have to narrow down your research field. In a water heater, flat plate, evacuated tube, parabolic disc collector. Likewise, around 10 different water heaters are there. First, you should narrow down your field. If it is flat plate collector, then you should focus only on flat plate. What is how many articles published into date in flat plate collectors? That you have to search in Google. In Scopus, you can see, and after that, you should download it from a different website like Elsewhere, Springer, Taylor and Francis, ASME, IEEE. You have to download and you have to read clearly and you have to found the new research gap. So research means a scientific and systematic search for a significant information on a specific topic. So this specific topic depends on your interest. If you are interested in biomass, then you should refer related to biomass. If you are related to mechatronics, then you should focus on mechatronics. If you are focusing wind turbine power plant, then it is further classified into two types: horizontal axis wind turbine and vertical axis wind turbine. So this is the narrow down your research topic. So see this flow chart. So here, literature review. That means you are going to refer the published literature related to particular field. So from the figure, it is very clear that from the literature review only, you can get objective, you can get problem definition, you can get methods and procedures. Also, from the literature review only, you can do your conceptual framework. So, literature review is very, very, very important in research work. So, without literature survey or literature review, you cannot start your UG research work, PG research work, as well as your PhD research work. So, it is the very, very fundamental for doing research. If you are belongs to ECE and you are ready to working on any sensor, for example, sugar level monitoring sensor or heartbeat monitoring sensor, then you must download the articles related to sugar level monitoring sensor or heart level monitoring sensor, heartbeat level monitoring sensor. You should download some literatures, latest literature, and you have to read what are the research already done by the researchers and what they have informed about their result, and you have to note down all the results, and from the literature review you have to identify research gap. So these are the techniques already available, but only few research focused on this field. So my aim is to focus this field, and I'm going to investigate and I am going to modify these things in the existing research gap. Likewise, you have to do the literature survey. So literature review is very, very important. From the literature review only, you will get problem definition, objective, methods and procedures, conceptual framework, everything. Also, we have to compare your present result with existing literature. It is validation. It is very, very important. So whatever results you are getting, you should compare with the existing result. So for all the things, literature review is very, very important. Next is conceptual framework. It is used to illustrate what you expect to find throughout your research. So if you refer 50 similar article, they have mentioned their major results. Okay, so from the published work, while you are doing literature survey, you should fix your upcoming result. That means your future result. So what is you are going to get at the end of your research work? So for example, if you consider water heater, then you should search for particular water heater. It may be flat plate collector. Then you should collect all the flat plate collector, and you should note it down all the flat plate collector maximum temperature and its maximum thermal efficiency. After that, you should see what the modification you are going to do and what is your expected outcome. That you can, that is the conceptual framework. So before getting your experimental results, you should think about what you will get. Okay, then you should consider your research work. You should do your research work, and you should get your result, and after that you should compare with existing literature. So you should construct only before you actually begin your investigation. So reviewing the literature. So after studying this chapter, students can able to understand what is meant by literature review, function of literature review, steps of literature review. First one, literature review. It is the documentation of a comprehensive review of existing work which is published in the specific interest of the particular researcher. It will be varying on person to person. So my research field is solar energy. So here I put solar still, desalination, solar PV, biogas, wind, hybrid vehicle, electric vehicle. So these are the some example. So once you identify the particular research area, then you should identify a specific topic. So solar energy means in solar energy, there are a lot of work is there. Solar application, solar distillation, solar water heater, solar greenhouse, solar cooker, solar dryer. Like this, there are so many works are there. So once you identify the area, then you should narrow down your field. After that, you should do the literature survey. So the literature review is an integral part of the entire research process. So without literature survey, you cannot complete your research work. Without knowing existing one, you cannot identify new one. So it is very, very important. Literature review is an integral part of the entire research process, and it makes a valuable contribution to almost every operational step. To find a novelty, you have to do literature survey. To find experimental procedure, you have to do a proper literature survey. To write a result and discussion, you have to do a literature survey. To write a conclusion, abstract, and to write a validation result, you have to compare your result with previous researcher work. For everything, it required literature survey. So without literature survey, you cannot do a good research. So it is very, very important for doing a research work. So first one, bring clarity and focus to your research problem. So you have to identify what is your research area. It may be solar PV, solar thermal, wind, biomass, biogas, nanoparticle, nanofluid. In solar PV also, concentrated PV. Similarly, in air pollution control, water pollution control, there are n number of topics are available. First, you should bring clarity. So for that, if you are student, you have to check with your faculty. For example, one faculty is working on particular field means you should approach that faculty and you should choose the topic related to the particular faculty working in that area. Okay, you have to approach the professor, and if they are working in environmental monitoring or pollution control, then you should take that particular topic and you should narrow down into a small area and you have to do your research. Improve your methodology. Okay, once you study the literature, you can get some clear idea about your research methodology. So broaden your knowledge base in your research area. So without reading literature, now I can say, if any person X or Y, they don't know about what I can say, remote controlled fan. They are thinking it is new. They are thinking that I am going to invent remote controlled fan. That means he don't know about recent trend. For that, he or she must read the literature, whether small remote control fan is available or not. So nowadays in the market also it is available. If a particular person don't know about the research gap, they must know about the latest trend by reading the literature survey. So without reading literature, if he or she thinks that I am going to develop remote controlled fan means it is what I can say, it is meaningless research. So very, very important is literature survey. It is used to broaden your knowledge base in your research area. Being clarity and focus to your research problem. You cannot effectively start the literature review search without an idea of the problem you wish to investigate. So you have to fix one small area, and after that you should search literature survey. So for example, in my field, in solar distillation, the performance of distillation is mainly depends on evaporation rate and condensation rate. Evaporation rate can be improved by enhancing the solar intensity falling on the water surface by using energy storage material, by using nanofluid, by incorporating solar water heating element, by integrating some solar water heater. Similarly, the rate of condensation can be enhanced by flowing water over the glass surface, blowing air over the glass surface. So, in that, I told 6 example. So, first I should select any one example. Performance improvement of solar steel using energy storage material or using nanofluid, or the performance solar steel by enhancing condensation rate by flowing cool water or flowing air. Likewise, I should choose one narrow down topic and I should check the literature. What are the different types of materials researchers worked on this field? The literature review can play an extremely important role in shaping your research problem. It is also helps you to define the relationship between your research problem and the knowledge in the previous research work. And it improve the methodology. It familiar with the methodologies that have been used by others to find answers questions similar to when you are investing. So, for example, if anyone are doing research in a solar cooker, so their major experimental methodology is how many hours it will take for cooking milk or cooking rice or producing hot water. So this is their major finding. For that, how they are investigating. So that has to be mentioned by yourself, and you have to do the same experimental setup, same experimental procedure for your experiment. And you have to note it down how many hours it taken for boiling rice, how many hours it taken for boiling milk, how many hours needed for producing hot water. Likewise, you have to note it down, and you have to compare with your result and existing literature results, and how your system is superior than others. Because you have to mention the resultant dictation. Tells you if others have used procedures and methods similar to the ones that you are proposing, which procedures and methods worked well for them, and what difficulty they have faced with them. Broaden your knowledge base in your research area. Literature review ensures you read widely around the subject area in which you are aimed to conduct your research study. It is important to know what other researchers have found in regard to the same or similar questions. What theories have been put forward and what gap exists in the existing research work. So already I told you how they have conducted experiment, what their results. You have to note it down and you have to do your research and you have to compare your results with their result. Literature review helps identifying how your findings compare with the existing body of knowledge. How to answers to your questions compare with what others have found. What contribution have you been able to make the existing body of knowledge. Now, procedure for reviewing the literature. There are 5 steps involving conducting a literature survey. First one, search for existing literature in your area of study. Review the literature selected. So first you should search and you have to select the literature and develop theoretical framework. So from the downloaded manuscript, you have to develop a theoretical framework. Next, develop a conceptual framework and writing of the literature review. Writing of the literature review. First one, theoretical framework. It defines key concept in your research, proposes relations between them, and discusses relevant theories and models based on a literature review. Search for existing literature. Start with at least some idea of the broad subject area. If you don't know idea, then you should check with your faculty what they are doing, what is their research work, how you can extend the particular research work. Like that, you have to identify and you have to fix it some topic. And here I have mentioned some links. First one is Science Direct. So simply in Google, you can type Science Direct and go to this one. Or now I will click and you can show it to you. You will click, cannot download the information. Okay, later I will show you how to download the manuscript, how to do a literature survey. So first one is a Science Direct. It is number one research publishing group. They have published n number of manuscript every year. And the second one is ASME, American Society of Mechanical Engineers. It is only for mechanical engineers. And third one is Springerling. So Springer is in second position after Elsevier, Springer. And John Wiley and Taylor and Francis. So these are the some good publications related to mechanical engineering. If you consider electrical, electronics, and computer science engineering, you can go IEEE. So these are the some common literature survey platform. Here you can search the literature. Okay, it does not goes to the page. So next, compile a bibliography for this broad area. There are two sources that can use a bibliography. First one, books, and the second one, journals. So very important one is journals. So if you are doing PhD, you are going to publish journals, not books. So you must refer a number of journals. For additional information, you can refer books, but I preferred only journals. So first one, be aware that sometimes a title does not provide enough information to decide if a journal is going to be used. So once you enter the keywords, for example, solar water heater, once you entered in Science Direct, you have to decide whether you are going to download this paper or not. So that you should check the abstract. So start with the latest issue. So similarly, you should check the latest article. Examine its contents page to see if there is an article of relevance to your research topic. Start by reading the abstract. If it is relevant, then download and read. So first you should see the topic, and then if you not get a clear idea about the research work, then you should read the abstract, and you can download and read it. So if your institution don't have Science Direct access, then you can use Science Hub, SCI Hub. So it is used to download research papers. I think last 2 years papers are not available in Science Hub. 22 and 21 it is not available. I think all the publications take some preventive actions against Science Hub. So actually it is a cracking website. Cracking website. It is unethically download the research manuscript without paying money to a publication. So all the publishers are against Science Hub. So they are planned to Science Hub. So up to 2020, you can download the manuscript. So after 21 and 22, you cannot download here. So if anyone wants any manuscript, you can type the topic and send it to me. I can download and I view. No problem. Only I have access for Science Direct, not for ASME, Springer. There are difference. Only I have access for Science Direct. Actually, Science Direct is the #1 research publication in the world. So if papers, you can get it from Science Hub. So now we will see what is Science Hub. So it is a website that provides free access to millions of research papers and books by mirroring official source, often by bypassing publisher paywalls in various ways. Science Hub provides many of the papers by ignoring copyrights regulation. So actually, we are publishing a paper. Publisher publish it. Once we publishing a paper, we have given full copyrights to the publisher. So I wrote the paper and I published it, but the copyrights belongs to publisher only. The publisher mentioned some amount. For example, $1,000 for downloading this manuscript. But maybe developed countries, they may give $1,000 for downloading manuscript. Whereas in developed countries, on undeveloped countries, they cannot download by paying $1,000. So I think one student, his name is Alexandra Elpakian. When she was studied his UG degree, after he seeing $600 rupees for downloading some papers, she was shocked. And why I have to pay these fees? At a time, she thinks about all other world, and she thinks it should be free cost. So she developed some tracking algorithm, and he hacked the LCR server. And whenever anyone download the manuscript, then she easily download without paying any fee. So I think she belongs to Kazakhstan, near to Russia. The site is widely used in both developed and developing countries, serving over, see here, 2 lakh requests per day. One day, around 2 lakhs papers are downloaded by using SciHub. So actually, while you comparing poor people, then it is good. But in their point of view, publisher point of view, she is doing some fraud, or he is hacked their website, and they are downloading the research papers so that their income may be decreased, so that they have complained a case against Alexandra, but still it is in process only. So in 2015, Elsevier filed a lawsuit against ScienceHub in Elsevier et al. ScienceHub et al. All the United States District Court for the Southern District of New York. So as a defendant in the case, which may be based in either the Netherlands or also in Russia. So it was the largest copyright infringement case that had been filed in the US or in the world at the time. Elsevier alleged that ScienceHub violated copyright law. ScienceHub violated copyright law and induced others to do so. And it alleged violations of the computer fraud and as well as inducement to the violate that law. So Elsevier asked for financial damages and banned to stop the sorting of the papers. At the time, the website was hosted in St. Petersburg, Russia, where the judgment made by the American courts were not enforceable, and the ScienceHub did not defend the lawsuit. In 2017, the court awarded Elsevier, that is $15 million in damage for copywriting infringement by ScienceHub and others in a default judgment. So see here, $15 million damage. So see, actually, European is a strong supporter of the open access movement and claims that ScienceHub's mission falls perfectly in line with the movement. She argues that websites like ScienceHub are part of the whole open access proponents and striving towards. European believes that via this open access movement, citizens can become more informed. In 2018, European asked supporters of ScienceHub to join their local private party in order to fight for copyrights forms to be changed, copyrights laws to be changed. So now what they doing, that is the publisher, what they are doing is they have introduced open access journal. So in the olden days, for publishing, it is a free cost, whereas to download, it is cost. In the modern days, for publishing, we have to pay the fees, whereas for downloading, it is free. So they are introducing more open access journal. For example, energy conversion and management. It casts on open access mirror journal of energy conversion and management X. Energy conversion and management is subscription based journal. That means we don't need to pay any amount for a paper publication, but download should be in it is in based on payment based. We have to pay the fees and we have to download. Whereas in energy conversion and management X, we have to pay the dollar to publish some dollar, maybe $3,500 to publish a paper. Whereas for downloading this paper universally, that is entire world, it is free of cost. So now all the journals are changing from subscription to open access. So review the literature selected. Now that you have identified several books and articles as useful, the next step is to start reading them critically to pull together themselves the issues that are associated. If you do not have a theoretical framework or themselves in mind to start with, use a separate sheets of paper for each article or book. Once you develop rough framework, top the finding from the material so far reviewed into the framework using a separate sheet of paper for each themes of that framework. As you read further, you go on slotting the information where it logically belongs under the themes for so far developed. Notice where there are significant difference of opinion among researchers and give your opinion about the validity of these differences. For example, some researcher told by doing this type of experiment, the performance has been improved. There is some researchers mentioned by doing this type of experiment, that is the same experiment, the performance has been decreased. Likewise, some controversial statement may be mentioned in the different researchers. So you have to clearly identify at what conditions they did the experiment and what conditions they did the experiment and how it differ. Likewise, you have to identify it and you have to choose your opinion. So here I have mentioned one review manuscript, review of different methods employed in pyramidal solar still desalination to augment the yield of fresh water. So first, your research work should starts with review paper. While you writing a review paper, you can know how to write resultant discussion, how to do a experimental, how to fabricate the experimental setup, how to do a literature survey, everything you know once you write a review paper. So for the particular topic, you should write your review paper. So this is one sample review paper. This wrote by me during my PhD work. Review of different methods employed in pyramidal solar still desalination system to augment the yield of fresh water. So from that different methods, you can fix any one method and you can improve the particular method, particular research work. So here I have classified into 4 types. That is passive solar still with energy storage, active solar still with energy storage. So these are here. I may have read over 10 articles related to pyramid solar still and 10 manuscripts related to pyramid solar still with heat storage medium and 10 manuscripts related to active pyramid solar still and 10 manuscripts related to active solar still with the heat storage material. So from the available material, after reviewed around 40 manuscripts, I can get some ideas what I can do. I guess I can think and I can do the survey. Develop a theoretical and experimental framework. As you start reading the literature, you will soon discover that the problem you wish to investigate has its roots in a number of theories that have been developed from different perspectives. Develop a conceptual framework. The conceptual framework stems from the theoretical framework and concentrates visually on one section of the theoretical framework, which becomes the basic of your study. Writing up the literature reviewed. While reading the literature for theoretical background of your study, you will realize that certain themes can be imagined. Let the main ones, converting them into subheading. These subheadings should be specific, descriptive of the theme in question, and follow a logical progression. Now, under each subheading, record the main finding. For example, already I mentioned pyramid solar steel with heat storage material, active solar steel with heat storage material. So under the each subheading, you have to record the main findings with respect to the theme in questions. So highlight the reason for and against an argument if they exist, and identify a gap and issues. How to write reference, book reference, journal reference. So Google Scholar, you can use Google Scholar. In Google Scholar, you can copy the title and here paste it here. Here you can get some citation format. Here MLA, APA, Chicago, Harvard. These are the some citation format is available. You can copy and you can use it in your review paper or research paper. Some tips for writing. The first one, write as you go. Don't wait until you have finished searching the literature. Set some times to write regularly and do it. For example, you can fix 2 hours time per day and constantly you have to concentrate on your research work. Start with the easier section. I think literature review is very easy as compared to resultant discussion. So literature review means just you are reading the existing research paper and you are writing what the particular researcher did and what their result, like as you have to write. So it is very easy. Planning, reading, and research, analyzing, drafting, revising. So planning means you have to plan every 1 hour. Reading and research, you have to reading. So without reading, you cannot find any research gap. And analyzing, you have to analyzing what they have used. What is the purpose of using this one? Next, drafting. You have to write. You have to write. You have to revise. You have to write. You have to revise. You should not type in computer. You must put your notebook and you write by your own handwriting. Then only it will be good. And you have to revise it. You have to read, and if you found any mistakes or error, and you have to revise it. So background, avoid background that are distracting or difficult to read from. Always be considered with background that you use. So commonly I have used Times New Roman 12 font, 1.5 line spacing. So now I will show you some website.
Rob, we can see your slide.
No, Professor,
Is
just
it
I am
finished?
leaving to other.
Oh,
Is
okay.
Science Direct is visible?
Yeah.
So actually, it is one of the, not one of the, it is the top website. Here we can see, for example, electric vehicle. So latest trend is electric vehicle. So here you can search it. Electric vehicle search. So fuel cell in electric vehicle, material and cell architecture of electric vehicle battery, and this is general parametric review. A comprehensive review of electric vehicle battery market. Like this. So in electric vehicle, then you have to see how you have to narrow down your research field. Whether you should focus on battery, or you can focus on design, or you can focus on material research, material design, battery. In electric vehicle also, some electrical and electronics components is there. Also some software engineer, also computer science engineering or IT field engineers also can use some sensors. So this is the how you can download or how you can search the particular topic. So my field is solar distillation. So I can search solar still. So here I can get n number of manuscript. So for doing research, you should take last 10 years document. So first I can click last 5 years document here. Okay. So after that, I have to check whether it is relevant to my particular field. So you should see the topic. Also, if you cannot found by using topic, then you should check abstract. So since I have Science Direct access, I can easily download. So I have access. So I can select all, download 10 manuscript. If I click it, then it will be download. So this is the how to download manuscript, how to using Science Direct. If you don't have access, then you should use Sci-Hub. SCIHUP, Sci-Hub. So last 2 years it is not properly working. So now I can search maybe 19 manuscript I can see. 20 manuscript I will see. 20. So new design of solar cell with the enhanced evaporation method. Comprehensive study. So here I should paste, then I should click open. So if it is available, I can easily download. Yeah, it is available. So it is 2019 manuscript. I think last 2 years manuscript we cannot access by using Sci-Hub. So it is a hacking website. So without paying money, I can easily download here. So this is the manuscript. So here they have developed one solar still, and they have used some external mirror. So the purpose of mirror is used to focus the solar intensity on the glass surface, so that it can produce more fresh water as compared to this existing methodology. So likewise, I can easily download the previous, that is before 2020, you can use Sci-Hub. Before 2020, you can use Sci-Hub. And now I can tell you how to use Scopus login. So already so this is my Scopus login. So the same keyword solar still I am copying. So it is pressing Scopus. So here in search, actually it is my profile. So here in search, you click search button and document. In document, I type solar still and search. Then I can know how many documents available in this corpus. So see here, in every year, 23, 500, 22, 300, everything is available. I can easily download this one. Export. It will take 2 to 3 minutes time. So I can download and I can, yeah, this is downloading now. I can see how many papers are available in the particular field. So before starting your research work, you can use Scopus and you can type your research field and you can download how many articles available. So if elsewhere, you can see only in Science Direct, you can see only what are the documents which has been published by Science Direct. Whereas in elsewhere, you can take all the publisher from ASME, IEEE, Taylor and Francis, everything they will connect and they have give the pakka result. Now I will open and I will show it to you. Sir, is PD Excel file is visible, sir?
Yes, yes.
Yes. Okay.
Yes, it's
So see
visible.
here. Yeah, thank you, Professor. So see here year is 1917. They have published solar still related. So you can see everything is here available, whether it is this conference paper or a research article, everything is available. So from that you can filter it. You can use sort and filter, smallest to largest, or you can click this one and you can take the latest one. So I think oldest version only it is downloaded. For I guess you can filter something and you can get it older papers which is related to solar stills. So see here solar stills in Iraq. So it is published on 1960. Energy balance in solar still 1961. So almost 100 years they are doing research in solar still desalination. Till now papers are coming in solar distillation. So you can search for like last 10 years, that is enough. You don't need to take 100 years literature survey, it is not required. So similarly, using by using this one Scopus, you can take the database for your reference. So this one is also very important. Also, you can refer author's profile. You can refer some particular author profile also you can see here. So how much papers they have published, what is their research work, what are their collaborators, everyone you can see. So this is my profile. Here top co-authors can be visible. So they are my top co-authors. Similarly, you can search anything for environmental engineering, air pollution monitoring, air pollution monitoring. You can see so many papers are available. Air pollution exposure monitoring using portable low cost air quality sensor. So like this water pollution monitoring, the smart sensor, sugar level monitoring sensor, sugar level monitoring sensor. Likewise, whatever topic you are interested, you can type it here. I think this one is a very new field, sugar level monitoring sensor. Only 19 papers it shows. Out of 19, I don't know how many is relevant to sugar level monitoring sensor. We have to see the abstract and we have to confirm whether it is related to particular field. If no article is available, then you should change the topic and or otherwise you should check the laboratory whether all the items is available in your university, then you can develop a new product. So research and invention both are different. Research means we should change a small modification, whereas invention is you are going to invent the sugar level monitoring sensor. So both are different. So likewise, you can search here and Science Hub will be useful. Scopus also useful for taking references. Hello, sir.
Yes, hello, Professor. So now it's open for Q&A. So if you have any question, feel free to ask. Any question? So, Prof, I have just a few questions to write. In your university, you have to write QE for a PhD before PhD. You have to pass QE, qualification exam for QE.
QE exam means, sorry, sir, I didn't get you.
Qualification exam for PhD student, do you need in your
No,
institute?
actually, it is very simple test only. I think maximum students will get pass mark. They have some question bank. It is available at university website. They can download and they can refer something. It is very simple questions only. Sir. They will easily get
Cool.
pass mark.
Okay, okay.
After,
and thank you so much, Professor. And yes,
after
Prof.
written test, they will have oral presentation. Two types of interview is there. First one is written test. Second one is oral test. So based on the written test and oral test, they will eliminate. They will given some mark and they will appoint.
Okay. Prof, I would like to appreciate your actually the lecture, especially last one, the how to writing manuscript or find manuscript and how to conduct the research. That's a great session. And also you talk about the basic from energy section, very basic to deep level. It was great and it's really appreciable. Okay. And we are due to actually our many virtual meeting. So everyone actually conducted, because whole university conducting their virtual visiting lecturer program. So that's why lack of members actually. Previously, it was 2021. It was many people join, at least 20 to 50 people, students. So now everyone busy moving, you know. So that's why, and it's also long time. So what we did, we just record the video and we upload our YouTube channel. And later on, we share with our student.
Okay, bro.
Okay. So do you have any question from you?
No, Professor.
Or from audience? From audience, any question?
No, for me.
Okay. So thank you so much, Prof. And I will proceed. Can you open your camera, Prof? I can see you.
It is open only, Professor. I don't know why it is not visible to you.
Okay. So I think that we'll see you one day and we'll still communicate it to you, because my field also solar energy. I am working on solar cell. So in future we'll have work, and thank you so much for your valuable
thank you,
time.
Professor.
And I will send the documents very soon.
Okay, thank you.
Thank you. And thank you so
much.
much, everyone. See you.
Okay, thank you.
Bye.
Bye-bye.